Welcome to Epsilon Pro Academy. In this lesson, we are going to consider one of the most important concepts of calculus, which is known as differentiation by parametric equation. It is considered one of the most important aspects because this is the aspect where most students find it difficult, especially when it comes to an exam. However, it is also interesting because there's a good news. The good news is that I'm going to treat this concept of parametric equation in calculus from scratch down to examination standard. Now, before we can step our foot into parametric equation in calculus, I'm going to give you a statement on the board. Now, the statement is now let's consider the statement on the board. The statement is, imagine your mom puts rice on fire. As time passes, here are the two possible things that will likely occur or transpire during when the rice is on fire. I represent it using letter X. So the first is the softness of the rice changes. And the second is, I'm calling the second statement Y. The amount of water remaining in the rice changes. Now I will leave you to think of what X and Y depends on, the factor that's making this statement to be correct. Now we are going to consider another statement. This statement could actually make you to get the right result faster, to get the right answer faster. Now the statement is, now here is the second statement. The second statement is, you charge your phone. As time passes, remember we are charging your phone in the presence of light. Okay, as time passes, the percentage in your phone increases. As your battery percent increases, and the remaining charging time for your phone to get to 100% decreases. Have you been able to figure out the right result? Okay, there's a hidden controller, and the hidden controller is time. Yes, the softness of the rice changes as time passes. Again, the amount of water remaining in the rice also changes as time passes. So that is to say, the first condition X and the second condition Y depends on time. Again, let us consider the second statement on the board. You charge your phone. As time passes, the phone percentage or the battery percentage increases with time. Also, the remaining charging time for your phone to get to 100% decreases with time. Now, this is basically the idea of a parametric equation. That is how it works. Now, let us represent this statement in terms of differentiation by parametric equation. Now, from this first statement, because condition X depends on time and condition Y also depends on time, we can also say that let X function of time. And from the second condition, Y, let Y be a function of time. Also, from the second statement on the board, since the first condition, the percentage or the battery percentage increases and is with respect to time, we can say let X from the first condition be a function of time. Let Y be a function of time. Basically, this is how it works. A function will be given to you where X will be a function of time, and where y will also be a function of time. Then you'll be required to determine the derivation of y with respect to x. This is very simple. Now let us consider one of the most simple examples on the board. Now let us consider this example on the board. The example is y is equal to 4t raised to the power of 3 and x is equal to 2t raised to the power of 2. The question is determine dy over dx. Considering what we have in this question, y is a function of t and x is a function of t. How do we get dy over dx? Now the observation is that this is quite different from what we did in our previous classes when we talked about chain rule, product rule, and quotient rule, even implicit function. But in this case, we are going to determine the derivation of each of the respective functions first. Now, in derivation, from what we did in our preceding class, we talked about how derivation works. If this type of function is given to you, or if this type of equation is given to you, because this equation consists of only two letters, it comprises two letters, y and t. The derivation of this function will be what? Yes, it's going to be dy over dt. Likewise as this, because there are two letters, this function or this equation comprises two letters, or it consists of two letters, x and t. The derivation of this becomes dx over dt. So that is the logic. Take note of this. So we are going to find the derivation of this and also of this. So from the first one, y is equal to 4t raised to the power of 3. So dy over dx is equal to, using this general formula, if y is equal to x raised to the power of n or ax raised to the power of n, the derivation of y with respect to x is going to be, use this to multiply whatever we have here, then subtract 1 from it. So dy all over dx would give nx raised to the power of n minus 1. We are using these principles to determine the derivative or the derivation of these two functions on the board. The derivation of this function becomes dy over dt. Dy over dt, not dx. So we have dy over dt, which equal to, applying that principles, 3 times 4, which gives 12. Let me not omit any step. That is 3 times 4. Then x raised to the power of 3 minus 1. So that gives 3 times 4 is 12. 12t raised to the power of 3 minus 1 gives 2. That is to say, dy over dt is equal to 12t raised to the power of 2. Let's do the same thing to the second function given. So in the second function, we have x is equal to 2t raised to the power of 2. Now the derivation of this function will be dx over dt. Therefore, dx over dt will equal to, applying that formula, 2 times 2, 2 times 2, t raised to the power of 2 minus 1, 2 minus 1. So this becomes 2 times 2 gives 4. 4t raised to the power of 2 minus 1 is 1. Let's omit the 1. That is the first step we are going to obtain in parametric equation. Now the next step is to either multiply or we divide. So we are going to evaluate dy over dt and dx over dt. After the evaluation, we must obtain dy over dx. So either by multiplication or by division. Let's bring these two. First, we have dy over dt, and we have dx over dt. Now, find dy over dx. How do we obtain dy over dx from these two combinations? The trick is very simple. Since dy is at the numerator, whereas dx is at the denominator, this is what we must do. At this point, dy is in the numerator. Over here, dx is also in the numerator. That means we have to bring dx to the denominator. So that becomes dy over dt times dt over dx, dt over dx. So at this point, this will cancel this, and we are going to be left with what? Dy over dx. So dy over dt is 12t raised to the power of 2. Dy over dt is 12t raised to the power of 2, whereas dx over dt gave us 4. And 4 is the same thing as 4 over 1. But what we obtain over there is not dx over dt. We got dt over dx. That means we are going to also obtain the reciprocal of 4t on the board. So if you are bringing this person down and this person up, we must also bring this person down, then this person up. That is how it works. So that becomes dt over dx will equal to 1 over 4t. Haven't known this, dy over dx will equal to dy over dt times dt over dx. And this is equal to dy over dt is 12t raised to the power of 2 times dt over dx is 1 over 4t. 1 over 4t. So this will give, from there, 12t raised to the power of 2 times 1 gives 12t raised to the power of 2 divided by 4t. 12 goes into 4 how many times? 3 times. 3 times. Then t raised to the power of 1, and this is t raised to the power of 2. According to the laws of indices, division law of indices, if we have a quantity divided by another quantity, then subtract their index. So that means it will become t raised to the power of 2 minus 1. And we obtain t raised to the power of 1, which is basically the same as t. So the final result becomes 3t.